Hey, what's up? It's Frank Lavinia here for datadriven.tv. First off, happy Monday, and just wanted to give a quick kind of update. So last week was Thursday, November 30th. I gave not a quick, but it was a webcast basically for Wintellect, my employer, a webcast on introducing data science for developers. A lot of the content was, coterminous, I suppose, with some of the material I've already posted, and it's also available for free. One of the questions that came up, there was something there I wanted to address, and came up in feedback and whatnot by more than one person. By the way, the webcast was excellently attended. We had about 500 people registered. Close to 200 people showed up. Which was all great, and hold on, I'm going to attempt to do this in real time. I'm trying out some new software here today. It's free. I just want to make sure I can catch all the chats that come up. Let's see. Alright, so nobody commented yet, that's fine. So what I want to do is I want to kind of walk through a couple of things data science-y, if you will. So the question was, or the commentary was, like, hey, a lot of this was high-level stuff, and there was a lot of code demonstrated, and let me show you why that is. I will go to my screen sharing app. There we go. In my swanky setup, see, you can still see my lovely face, but here's the code. So this is from the just basically an iris classification data set, and kind of the code that comes with ML Workbench. By the way, ML Workbench, if you're curious about it, my article in MSD Magazine went live on Friday, so you can check it out, kind of a overview of ML Workbench and kind of how it differs from ML Studio. Again, there's not a lot of code in that, and you are about to see why. If you go down, so this is the line of code that basically uses scikit-learn, and if you look, the code file is about 107 lines long. The code that actually does data science, that does machine learning, that actually does the magic, if you will, is very small. In fact, if you look here, this is it, line 56. Line 56 is, and this is why I didn't really mention it, because I was basically doing kind of an example, a thought experiment of image classification. The code to do image classification isn't much more complicated, but if you look of this code, so line 56, we have one line of code. Most of it, if you look here, right, so everything here from 1 until line 25 is mostly just imports and kind of just setting up the environment, right? Make sure that there's an output directory, because you'll see later I'll do that. This here is running a dprep file, which is ML Workbench's data cleansing tool. And basically what I'm doing here is separating the data, all the columns that I'm not interested in predicting. The columns I want to feed into it basically become the X data set or data frame. The value I want out, what type of species this this squirrel ran by. I just saw a comment go by. The data that I want out is that I want to predict. So in this case, it's the species of iris. And then I do some kind of, I intentionally put noise in the data so it has something more to grip onto, but don't worry about that. And this, I split the data into basically, in order to train a data set, you need to take the data and you have, right, in this case it's measurements of irises, and there's pale and sepal length, and then you split that into usually 60-40, in this case it's 35-65, into data that you're going to train the model on and data you're going to test the model on. We'll get to that in a second. And then this reads in a regularization rate. Don't worry about that just now. But basically what I do, I create a logistic regression model. Don't worry about it if you don't understand exactly what that means. But basically, this is the part that's actually training the model, line 56. Then I do some testing on it, right? So remember, I split the data into a chunk to test and a chunk to train on, and a chunk to test. This is basically I'm saying, okay, well, you know what? Score using that model. Tell me how well you do. And then we go down later here. We do print out some stuff. What you'll see here, I'm going to load a model, and then I'm going to punch in some data, and then out here basically comes out a result when I do predict, and it will tell me what it thinks. So essentially, 109 lines of code. You can count the values of lines of code that have actually real data science associated with them on one hand, possibly even less, if you want to be strict about it, right? So I separate the data. You can say, well, is that tangentially, machine learning or not? But essentially, I load the model on line 56, and I fit the model, which is basically training it. And then I run a prediction on it, and I score it. So 3 lines of code directly related to machine learning, and kind of maybe, 3 more on tangentially associated with it, splitting the data and then scoring the data, not even scoring the data, just reporting the metrics, what's its threshold and things like that. So that's why this, in the webinar, I didn't go into the code, because shockingly, there's not a lot of code. Actually, that's not true. It's 109 lines of code, but most of it is scrubbing and cleaning the data. And that's really, you hear the statistic of, 90% of data science, or 50, somewhere between 50 and 80 to 90% of the job of the data science is cleaning data. You see that bear out here, right? So 3 plus 3, so we'll be generous, we'll say 6, right? So 3 are directly related to data science, and 3 more lines of code, more or less, are related to structuring of data and things like that. What you're not seeing is some of the work that the dprep package actually does, which, read my article, kids. Maybe I'll do another live webcast. If click like if you want me to do another one of these. And I can even change this out for a fancy studio. This this virtual, and I can also point the camera in another direction and kind of do this on the whiteboard. But one of the I just want to do this real quick while I was playing with some new software. But the key here is let's run the numbers here. Calc. And where did my calculator go? There we go. All right. 109 lines of code. Let's see. 3. Oops. So 3. Let's say 6, right? Because there was 3 directly related to machine learning and 3 kind of tangential to it. So we'll say 6 divided by 109. So, oops. Go back here. Times 100. 5.5% of the code was devoted directly or tangentially to data science, which means, 94.5% had nothing to do with data science. And if you look, that's not uncommon. And granted, not all lines of code are created equal. I get that. But that's just it. The code to show it wasn't really worth showing. And there was more important in the 45 minutes that I had to explain some of the context of this, right? Why is this different? Why is data science different than software engineering? And basically it comes down to you don't write algorithms. You implement algorithms that are already written, right? Now, if you really want to know the ugly details, and there's plenty, download or take a look at the source code for sklearn, right, or scikit-learn, and you can actually dig through that code, and that's plenty. But the key here is that for most people who are going to be data engineers or applied data scientists, right, the non-academic crowd, you're not going to have to worry about that, right? Logistic regression is logistic regression. A binary tree is going to be a binary tree. That stuff's kind of been written and already well figured out. there is a chance that you will need to dive into that, and a very slim chance at that in the future. But for the most part, you just have to understand the algorithms and have a decent appreciation of how they work. But for the most part, you don't really need to have that mathematical background. It does help, but I mean, that's the key. And I probably should reload on some coffee because I am starting to stammer. But I just wanted to give you this quick kind of data point. I will post in the Facebook feed for those who have no idea what I'm talking about. The link to the webcast. I think went really well. A lot of positive feedback. But again, I didn't want to leave that stone unturned, and I also wanted to drive home the point that I do read the feedback, which is cool. You know, I'm a big boy. I've done this for many, many years, and you know, if you think something I presented sucks, don't tell me that it sucks. Well, just tell me that it sucks. Tell me why, right? So I want to improve on this. I know the audio on this is not ideal. I don't have the stuff hooked up, the lav mic and things like that, but I will get that going. As you can see, I didn't have time to set up the lighting. I just want to do something real quick, explain this, and thank you for all for watching this. And if you attended my webcast, thank you for attending that. If this proves popular enough and I get enough traffic on this, maybe I'll do some more of these kind of impromptu data science-y sessions, and maybe even some code, kids. You know, there is code with data science, but you see there's just not quite a lot of it. All right, and with that, I will go back to my fancy pre-roll graphic that I put so much heart and love into, and then end the stream. You have a great one.